Okay, today we're going to do twofold. One of the things we're going to do is start graphing again. And so these first couple of problems are actually from Unit 1, and then we'll go into how we do this a little bit differently now that we're in Unit 2. So these first few problems are from Unit 1. So this is just a review of what you did in first chapter. When we started these, this is in our vertex form. So if you don't remember that, that is your f of x equals a times x minus h squared plus k. And what we did is we used this form to figure out our important characteristics and be able to graph from there. So first off, what we know is our vertex is always at hk, because how you moved left, right, up, and down affects where your vertex is at. Your a value then will stretch, shrink, or reflect your graph. So the first thing with this one that we want to identify is where our vertex is at. Because of our 2 and our -1, my vertex is at 2, -1, because this 2 goes right and this 1 goes down. So my vertex automatically is over here at 2, -1. What we immediately did then back in chapter 1 is we said, okay, this 2, -1, I'm going to make it the center of my graph because I have an axis of symmetry that my graph will reflect over, and I can use that to make my life easier. So we put 2, -1 in the middle, and then we plugged in 2 to the left and 2 to the right. You're going to want to take a second and plug those numbers in to your vertex, remembering that 1 and 3, not to your vertex, into your equation. 1 and 3 will have the same y value, and 0 and 4 will have the same y value. When you plug in 0, 0 minus 2 is -2, squared is 4, times 4 is 16, minus 1 is 15. So at 0 and at 4, your y value is 15. When I plug in, say, 3 minus 2 is 1, squared is 1, times 4 is 4, minus 1 is 3. So these will both be at 3. When I look at this graph gets really tall really fast. I frankly can't even plot the 0, 15, but that's okay because the 4 stretched my graph. My graph is super tall and skinny because it was stretched by that 4, so that's okay. Then we're going to go through and fill in our characteristic chart. Left to right was -infinity to infinity because I can plug in anything I want. Range again is bottom to top, so the lowest value here is -1 and the highest value is infinity. Again, in your limits, you're going to fill in your -infinity and your positive infinity. This is the left of my graph, this is the right side of my graph, and you're telling me where it's going. Okay. During first chapter, we actually didn't do this part because it was going to be a lot to handle that first chapter, but now you've done it, so we are going to fill it in for everything. On the left side of my graph, it's going to keep going up forever, so it's going to be f of x equals infinity. On the right side of my graph, it's also going up forever. So our limits on this one match. That's not always the case. We have added a new line to this one, and this one is called your relative extrema. Okay, what relative extrema means, it is locally, I'm going to write this down below, a local high or low point. Okay, it is not necessarily the highest point overall or the lowest point overall, but in that region, it is the highest or lowest. In terms of a maximum, we actually do not have one. There is not one point that is the highest of any nearby points. However, we do have a minimum, and that minimum value is my vertex. This is the lowest point overall. It's also the lowest point in the region. Okay, your vertex will either be a max or a min, and so you'll have to figure out if it's a high point or a low point. For your increasing, decreasing, this right side of my graph is increasing. Again, you read this left to right. You tell me the x value where it turns around. So it starts increasing when x is 2, and it increases until x is infinity. For decreasing, it's from where x is -infinity all the way to when x is 2. And make sure on that turning point that it is parentheses. For your x-intercept, this is where we're going to set it equal to 0 and solve. And you can actually do this a couple different ways. I'm going to show you a way you might not have thought of yet, just to give you exposure to that. But know that you can use any of your tools from the first half of the unit to be able to solve this. So you could FOIL out that binomial, use quadratic formula, use use factoring, whatever you can to solve this. But I'm going to show you a way you might not have thought of. What I'm going to focus on is isolating this x minus 2 squared. So I'm going to add the 1 and divide by 4. And you get 1/4 equals x minus 2 squared. What we learned this chapter is that in order to undo this squared, I could square root both sides. Okay? When I square root, it's important you have a plus or minus. But this square rooting the 1/4, I can square root 1 and that gives me 1. I can square root 4 and it gives me 2. And set that equal to just the x minus 2, because on the left side the squared and that square root cancel. Then you're going to solve this, so I would add 2 over. So x is equal to 2 plus or minus 1/2, and then we can do that. 2 plus 1/2 is 2.5. 2 minus 1/2 is 1.5. So my two x-intercepts are 2.5 comma 0 and 1.5 comma 0. Okay, and again, I would look at your graph and make sure that works out. When you are graphing, I'm okay if you give me a decimal point here to help you approximate if you actually did it correctly. So your x-intercept here can be a exact value, or it does not have to be an exact value, because you want to be able to check with your graph that it actually worked out. For your y-intercept, we're going to plug in 0, which we actually already did. So I'm just going to steal this off of myself right here, and my y-intercept is at 0, 15. Okay, so this should not be new. All of this we did during first chapter. What I want you to do is take a minute and try to do this one. Make sure you remember it, and then unpause the video and we'll go through it together. So the first thing I'm going to do with this one is find my vertex. It did not go left or right, so it is at 0, but it went up 4, so 0, 4. That 0, 4 again goes in the center of your graph. And I'm going to plug in 2 to the left and 2 to the right. When you plug in 1 or -1, you should get out 1 as an answer. And when you plug in 2 or -2, you should get -8 as an answer. So make sure you did get those. My graph is stretched, which is good because there's the 3 there. It is also reflected, which is also good because it was a -3x squared. Remember, you can check your graph as you go, and that will help you a lot to make sure you're doing it correctly. To check your characteristic chart, my domain is -infinity to infinity. Range is bottom to top, so the lowest value is -infinity, whereas the highest is this 4. So it's going to be -infinity to 4. I'm going to fill in my left and my right. On the left side of my graph, it's going down forever. So this is going to be f of x equals -infinity. On the right side of my graph, it's also going down forever. The end behavior on all of these will actually match. This time we do not have a minimum, and we instead have a maximum. My vertex is at 0, 4, and that's the highest of any point in that region. So that's going to be my maximum. For increasing, it is increasing on the left side of the graph now. So from when x is -infinity to when x is 0. Remember, these need to be your x values. And it is decreasing from when x is 0 to when x is +infinity. It is going to the right. For your x-intercepts, again, we're going to set it equal to 0. And I'm also going to solve this one by square rooting, but you could do quadratic formula, whatever you need. So we're going to subtract the 4, divide by the -3, which will give me 4/3 equals x squared. You're going to square root both sides, and x equals plus or minus 2 over root 3, which if you rationalize, this gives you 2 root 3 over 3. Again, what I said on the last one is if you want to give me this as a decimal, that is fine. On the test, you will have to make sure to be able to give it to me both ways, because when you're solving, I will expect it to be an exact value. When you're graphing, I want you to be able to check it. If you type this in your calculator, you get about 1.15. The reason, again, that I care about that is I want to be able to look at my graph and make sure that that seems reasonable. These seem to be crossing at about that plus or minus negative 1.15, so that means I probably did it right. If you leave it as an exact answer, if you leave it as this 2 root 3 over 3, you don't necessarily know if you did it right or not, so do make sure you're checking that out. My y-intercept, I also did that already when I found my vertex, so I'm just going to fill it in. Okay, so this should be a review from last time. These should be things you have done before. And now we're going to turn this around a little bit and start graphing in what's called standard form. In standard form, that means your equation is given to you in the form ax squared plus bx plus c. And so what's tricky, really the only thing that's going to change is this entire thing. When it is in vertex form, you can look at your equation and you directly know what your vertex is. We immediately knew our left or right and our up and down. With these ones, you do not. So your first step is really all that changes, and you have to find your vertex differently now. The way you find your vertex to get your x value, you have to calculate it by doing negative b over 2a. This you will have to memorize. We will never give this to you on a test. But then from there, once you know your vertex, you're going to still create your t-chart. And then you're still going to do your characteristic chart. So nothing else at all changes, except for how you find it. Okay, so to find my vertex here, I need to do negative b over 2a. So my a value is negative 1, my b is negative 2, and my c is 4. So b, negative 2 gives me a positive 2, divided by 2 times negative 1. That means my vertex, when I calculate this, this is 2 over negative 2, which is just negative 1. That negative 1 value is the x-coordinate of your vertex. It does not tell you your y, but it is your x-coordinate. You do have to plug that in to get your y value. So that is the other change here. You don't have any y values. When you start, you have to be able to do them all in your calculator. Okay, when you plug in negative 1 to this original equation, you should get out an answer of 5. So make sure you practice doing that. But then we're going to plug in negative 2 and negative 3, 0 and 1, and again, you still have this axis of symmetry. The only thing that's changed is how you identify your vertex. What I want you to do, take a second and practice plugging these in and make sure you get the numbers that I have in my chart. Okay, if you don't, make sure you come see me to ask a question so that I can help you. But these should be the answers you get. Okay, so that is what your graph should look like. The rest of this is really exactly what we already did. So again, the only difference is how you find your vertex. Okay, what I would do is make sure you've taken a second and gone through and actually filled in the chart before you listen to me explain it. But I'm going to go ahead and talk about it. So pause it if you're not ready. The domain is the left to right. All of these will be negative infinity to infinity. Range is bottom to top. So this is negative infinity up until a high point of 5. Okay, the limits, my left and my right. So on the left, it's negative infinity. On the right, it's infinity. But where it's going, both ends are going down. So both will be f of x equals negative infinity on both parts. Okay, this has a maximum, not a minimum. The maximum is at negative 1, 5. Again, right, none on the other. It is increasing on the left side of my graph, so when x is negative infinity to when x equals negative 1. It is decreasing on the other side, so when x is negative 1 to when x is infinity. For the x-intercepts, you are going to set it equal to 0. What I would do with something like this, I hate having all those negatives, so I would factor out the negative. Okay, which technically then the nice thing, I can divide both sides by a negative 1, so my equation is really x squared plus 2x minus 4. with these, I would look at it and think about, we know from looking at this that there is not a nice pretty x-intercept, which means more than likely you're going to have to do quadratic formula. But you could technically quadratic formula or factor these, you're never going to know for sure. When I go to quadratic formula this, because again, if you try to factor it, it's not going to work, you're going to have -2 plus or minus the square root of 4 minus 4 times -4 times 1 all over 2 times 1. Okay, that is going to end up giving you -2 plus or minus 2 root 5 all divided by 2. So take a second and simplify that radical if you're not sure how I got that. Which again, if we simplify this, -1 plus or minus the square root of 5. So that would be good practice to keep doing. But what I would also encourage you to do on these is make sure that if you type it in, your answer makes sense with your graph. So if I do -1 plus the square root of 5, I get 1.2 approximately. If I do -1 minus the square root of 5, I get -3.2. And I would look at your graph and make sure that those make sense. This seems to be approximately 1.2, and this seems to be approximately -3.2, so those are probably good answers. Okay, and then again, my vertex I already did in the chart. It's 0, 4. Or not, sorry, not my vertex, my y-intercept. Go ahead and give this one a try. And then again, make sure once you're done, unpause it and I will walk you through it. Okay, this one gets a little bit uglier, but that's okay. When we go to find our vertex, -b, so -4 is +4 over 2 times 3. Gives me 4 over 6, which simplifies to 2/3. So when I go to my chart, I'm going to put 2/3 in the middle. Now, really what's going to happen here is when I go to use my axis of symmetry, it's not going to work perfectly because I'm not going to plug in fractional exponent or fractional numbers everywhere into this problem. What I'm going to do is still just plug in things left and right, but I'm going to use the nearest whole numbers. Again, what that means for me, I'm not going to expect the axis of symmetry to work perfectly because they're 0 and 1 are not the same distance away from my vertex. When you plug in -1, you should get out a 2. When you plug in 0, you should get out -5. When you plug in your actual vertex, you should get -6 and 1/3. When you plug in 1, you should get -6 and 2, -1. So again, these don't mirror perfectly, and that's strictly because they're not the same distance from my vertex, but I wanted to use whole numbers instead of ugly numbers. 1 is at -6, 0 is -5. So again, when I plot these, it's not going to be quite as pretty as we're used to, but it still makes that nice parabola shape. When I go to do my domain, it's still -infinity to infinity. Range is bottom to top, so -6 and 1/3 to infinity. On the left side of my graph, it's going up, so it's going to be infinity. On the right side of my graph, it's also going up. This does not have a max, but it does have a min at this 2/3, comma, -6 and 1/3. It is increasing on the right side of my graph, so from 2/3, again your x values, to infinity, and it is decreasing on the left side, which means from -infinity to 2/3. For your x-intercepts, we're going to solve that by setting this all equal to 0. Again, this one doesn't appear to give me pretty answers on either side of my x-intercept, so I'm going to have to go ahead and quadratic formula this. So we have 4 plus or minus 16 minus 4 times 3 times -5 all over 6. Which gives me 76 under that radical. When I simplify it, 76 is 4 times 19. So this is 4 plus or minus 2 root 19 over 6. And a 2 goes into all of those. So this is going to be 2 plus or minus the square root of 19 all over 3. Again, to help you approximate, I would actually type that into your calculator. So 2 plus the square root of 19, and then divide it by 3. That gives you about 2.1. And 2 minus the square root of 19 gives you about negative 0.78. Okay, both of those seem totally plausible based on my graph, and that helps you to know that you're probably on the right track. For our y-intercept, again, it's whatever you get when you plug in 0. We've already plugged in 0, so I'm just going to fill that one in. What's important here today, I want you to see how similar it is to graph either method. You will have one of each on your test, and so I want to make sure you know how to do it from either direction. But what we're going to talk about next is actually how you can convert back and forth between both forms. So if I give it to you in Vertex form, you can actually rewrite it in standard form if you want to be able to graph everything that way. And vice versa. If I give it to you in standard form, but you want it to be in Vertex form because you prefer graphing with that method, there is a way to transfer it over. So that's what we're going to talk about next. Okay. Going from Vertex form to standard form is actually way easier, so I'm not going to really write you anything here. I'm just going to show you how to do it on 5 and 6, mostly because I'm going to need some of this space to talk about the other method. So I'm just going to cross this out. Okay, if you are going to take this equation number 5 here and convert it into standard form, what you're going to do is you're just going to expand it out and do all the operations. So the first thing you want to deal with is this squared. So remember that when you square a binomial, you're going to write it twice in FOIL. So it's going to start like that, and you're going to FOIL it out. Take a second and do that. Oopsie, it's not equals. But you should get that. Once you've FOILed your binomial, we're going to distribute the 4. So this is 4x squared minus 16x plus 16 minus 1, and then combine your like terms. So in standard form, this would be my equation. So these two will graph me identical functions, but again, depending upon how you prefer to graph, you could put it in the other form to be able to do it more easily. Go ahead and do the second one, and then check it with my work when you're done. Pause the video if you need more time. Okay, but this would be my standard form equation of that function. Again, some people just prefer to graph it from one way or the other, and this lets you do that. Okay, what we do for the rest of them is a little trickier, and it's what's called completing the square. Okay, and what I'm going to do real quick is just switch viewpoints, and I want to look at these. So go ahead and take a second, and whether you do it in your notes or just separately, I want you to factor these 3 problems. And when you're done, unpause it and I'll go through them, and we'll make sure that you factor them correctly, and then talk about some patterns that show up. Okay, when you factor this first one, multiplying to 25 and adding to 10 should be 5 and 5. When you go all the way through your work, what you're going to end up getting is m plus 5 squared. You should have 2 m plus 5s, again, stemming from the fact that you had the same number here. Okay. When you factor this the r squared minus 4r plus 4, multiplying to 4 and adding to negative 4, well, that's negative 2 and negative 2. So again, it's the same number, and you end up with r minus 2, the quantity squared. On this last one, multiplying to 9 and adding to negative 6, again, the same thing happens, and it ends up being 2v minus 3s. What all 3 of these are called is perfect square trinomials. And what if we can have a perfect square trinomial, then it lets us get that major part of your Vertex form where you have something added or subtracted squared. And so if we can find a pattern that happens here, then we can kind of repeat that when we're going to complete the square on our other problems. So what I want you to notice, if you look at this first one, think about how the number with an m is related to the number that ended up in your parentheses. So how is this 10 related to the 5? Then I want you to see, is it the same relationship with the -4 and the -2, the -6 and the -3? So take a second to think about that. What I hope you noticed in all of them, whatever ended up in the parentheses here was exactly half of your b value. Okay, so -4/2, this divided by 2 gave you what was in your parentheses. Okay, now if we take it a step further, how is this one in the parentheses related to the last number in your trinomial? In each case, what I hope you notice is that it's just that number squared. So 5 squared is 25, 3 squared is 9, 2 squared is 4. So this pattern is what we're going to force as we go through this next slide. In order to complete this square, and you can fill this in on the notes where I changed it to say complete the square on the other one, the first thing you're going to do is you need to do half of your middle term. So we're going to do b over 2. When I look at this one here, b over 2 here is just 8. But the thing we would have to add to this is whatever is squared. So we're forcing this binomial here to be a perfect square. So I'm going to add 8 squared, or I'm going to add 64. So again, take your middle number, cut it in half, and then square it. I don't know why I wrote squared. Square it, sorry. If I added 64 to those two terms, what I would have is a perfect square trinomial. And so I'm going to factor it to show that. If you take a second and factor this, what you should get is a plus 8 squared. Make sure you get that. Feel free to pause it if you need more time to do it. The nice thing is this can be duplicated anywhere. So here if I do 34 divided by 2, I get -17. When I square that, we get 289. So I'm going to add 289, but then go ahead and factor it. And what you're going to get is n minus 17 squared. Last but not least, to figure out what we would have to add to this, divide it by 2. So that's 6. 6 squared is 36. And again, if you go ahead and factor it, you get x plus 6 squared. So this is the process that we're going to do when we have the problems that we want to convert into vertex form. Okay, so to actually do that, so again, I would have filled in those steps here if you're using the Schlitz notes. How we're going to do it on the ones below. To actually convert, the first thing I would do is separate your ax squared plus b from your c. So how I'm going to do that down here is I'm really just going to group the x squared plus 6x together, and I'm going to leave the 4 off to the side. If you can, you need to GCF your a value from the first two. So if you have an a value of anything besides 1, you need to factor that out. If you don't, you'll just leave it. So on the one we're about to do, number 7 here, we're not going to get to factor an a value out. Our a is 1, and I'm not going to factor out the x's. Okay, just think about a GCF of a number. Okay, then you're going to complete the square of your first two terms. So here I'm going to have, I write them out a little bit bigger now, and I separate my 4. So if I cut 6 in half, I get 3. 3 squared is 9. What's extremely important, we are not allowed to just randomly add 9 to a problem because we feel like it. So when we complete this square, we need to cancel out the math in the other part of the problem. So since I have added 9, the only way that that doesn't change my problem is if I also subtract 9. Okay, then you are going to factor and simplify. Okay, so when I factor the first part, multiplying to 9 and adding to -6 is -3 and -3, so it's going to be negative x minus 3 squared. And then 4 minus 9, that gives me -5. This is my standard form equation of the function I was originally given. How this can make it easier for people is it's easier to find your vertex. Right now I know my vertex is at 3.5 because of this vertex form. I could also still find that in the older, if it was given to me originally, just by using negative b over 2a. So again, here my b is negative 6, so negative b is 6 over 2 times 1. That still gives me a vertex of 3. That's why those match, but now I don't necessarily have to work quite as hard to figure out my vertex. If we do this to number 8, number 8's one we're actually going to have to do that step of GCF factoring. So I'm grouping these first, and what I look at and see that x squared has a negative 1 in front of it. So I need to factor out that negative 1. So I'm going to rewrite this as x negative, parentheses, x squared, plus 8x, because I factor out the negative. But I'm not going to do it to the 13, because the 13 needs to be added or subtracted out back. When I complete the square, again, I'm only looking inside, so 8 divided by 2 is 4. 4 squared gives me 16. This is where it gets a little tricky if you're not paying attention, so please be careful here. What I really did, I added 16 here, but this 16 is multiplied by a negative, so I really subtracted 16 into my problem, which means to cancel out a negative 16, I need to add 16 out back. Okay, so this changes based on if you factored something out or not. But then I can go ahead and factor. And what you should get when you factor the front part is x plus 4 squared. You have that negative in front still. And then plus 3. So this would be my vertex form. Okay, we're going to go ahead and do the challenge problems also because of the fact that there are some of these on your homework and we want you to be prepared. If you want to try them first, that would be an excellent idea, and then go ahead and play it to listen to me talk through it. So again, first we're going to group these first two terms, and I'm going to GCF it. If you look at these, I can pull out the 2. You should always pull out whatever your a is. So this will be x squared minus 10x, leave some space, and then plus 40. 10 divided by 2 is negative 5 squared. I'm going to add 25. Okay, but what you have to remember is you didn't really just add 25, you added 2 times 25, which is 50. So I need to cancel out a positive 50 by subtracting 50. Then when I go to factor, you should get x minus 5 squared minus 10 with that 2 in front also. So this is your equation in vertex form. Last but not least, same thing, feel free to try this one before listening to me talk about it. From these two, you always want to pull out your a value. So I'm going to pull out a half. Remember that when you do negative 2 divided by a half, that's really the same as doing negative 2 times 2. Dividing by a fraction is the same as multiplying by your reciprocal. So this is minus 4x, and then this plus 3 is out back. Doing negative 4 divided by 2 is negative 2. Squared tells you to add 4. And then my equation, when I factor it, should be x minus 2 squared. Oopsies, I forgot to add it. Sorry. You do half times 4, because that's really what I added here. Half of 4 is 2, so I need to cancel that out by subtracting 2, so plus 1.